All right, here we go. Let me show you where these things are. All right, so in the locker, you will find down here the JSTracker web browser video tracking. This is the one that you want. And then inside here, tracker practice videos, cork drop and cork roll. We will take a look at the cork roll one. The cork drop will be there as well. I'm recording this so that way if you want to walk through with me on this video, and then you'll know that you're doing it right if you're getting a number that's pretty close to what I'm getting. So let us, I have it as a shortcut because I already like that. All right, it's going to ask you for a backup, something that you did earlier. That's nice if something cuts out and you want to pull up the data that you forgot to save. Would you like to recover this? No. Would you like to delete from storage? Yes. All right. You have to get yourself a video in here. MP4s are, I think, the only one that it takes. So if you've recorded it in something else, you do need to change that. Cloud convert is one way to do that. You can change it on whatever video you've got, camera you've got. And so let's just do the cork roll. Where was it? It was in, it's on my desktop. Did I have it on the desktop? No. I moved it. Cork roll, cork roll. There it is. Open, here we go. Please make sure that the size of your video is small. It will directly impact how well this program can manage it. If you have a 4K video of you rolling a tin can down a board, figure out somehow on how to make it smaller. It will upload faster and it will allow you to the program to work better, and then you won't get blank screens, white screens that happen every so often. It's because the picture is just too big and the program can't handle it. And remember, it's not how long the video is, it's the file size. So make sure that you see if you can export it as 480 or 720, something like that, 480p, 720p, something like that, not highest. You don't need a high-res video of you dropping a rock. All right, so here's your new project. When you get your new project, this is the cork roll. This is 6th period. Frame rate is 30 unless you've got something else, like a you're going at high. You're super slow speed, like you've got a slow motion video, at which point then you would have to figure out what your frame rate is. The easiest way to do that is to read it, but many of your cameras won't tell you what the frame rate is. They'll just tell you it's a slow or super slow-mo, but they won't tell you how many frames per second it is. So you have to go in and figure out, you put a timer somewhere in the in your video when you're doing a slow motion video, so you can figure out how many frames it is for it to move 1 second. Because this is frames per second. This is 30 frames per second. I'm going to move 1 every time I click. I'm going to, the speed of the video is 1, which just means slow. As you are playing it in the program, axis color, I like yellowish. Doesn't matter because I'm colorblind. Points before and points after. This is helpful as you are going along to tell you about how many points behind. You get to see your previous 7 clicks, which doesn't make a whole lot yet. And then it points ahead of the current time, or when you're playing the video, how many points ahead. We'll put 3 in there just so you can see what it looks like. Here we go. Here's my video. I will play the video first so you can see what it looks like. This is playing at speed 1, which really doesn't mean a whole lot. All right, and there's the cork rolling down. All right, so I'm going to stop that. This is that play button. If you hover over the buttons in here, it does nicely tell you what they are. So let's see here. All right, next. You saw that when I played, really didn't let go of it until about here. So this slider tells you about where you are. And so I want to be, this is where it is. And these little triangles at the bottom, the left triangle tells you that this is where you want t = 0 to be. So I will put that right about there. Okay, that's all right. And this is where the last, where you just want the video to stop at, or at where you want the video to stop. All right, so let's see, it rolls down. And then it starts over again from that same spot. So I want it to stop roughly about there. Okay. There's the piece that I'm interested in. Next, you can see my yellow axes that are on there. I'm going to move that around by grabbing here in the middle. So when I come over to the middle, it turns into a hand. If I press and hold, if I click and hold, you can see that I grab the axis, then I let go. Then I grab the axis, then I let go. Then I grab the axis and I move it. And then I move it. And then I move it. And then I move it. Over here on the right is this little nubbin. That little nubbin tells you that is the positive x-axis. And so think that one is like the, one click, or one, that is the axis that is positive, pointing in that direction. So it's also a right-handed axis. So in this situation, the one to its, if you look down, you just take your finger and point along the x-axis, and then bend your middle finger towards, that's the one that is towards yourself. I guess you can go that way. That means this one up here is the positive y-axis. So I'm just going to start kind of over here at the bottom. It's a good place to start, good as any right now. Here is my ruler that's laying on the ground. That tells me that. I also have the door frame over here that's telling me what is level. So I'm going to make the bottom, make these two lines parallel, make the axis and the bottom of the door parallel, because I know that the bottom of the door is pretty level. Let's see here. So if I'm not here and I move over just a little bit, it turns into an up and down arrow, which is a little bit deceiving. It really should be a curved arrow, because when I click, hold, and move, it twists the axes. So now you also notice if I'm right here just a little bit, it's kind of hard. It's kind of hard for me to figure this out. If I come farther out, now I've got more control. So I kind of like it like that. That's not half bad. Now when I move, well, look at it. I got that line up pretty well with my ruler there. So let's line this up. Now this is a nice axis. I'm going to put the axis at the bottom of it. Little hint, it doesn't really matter where you put it. All right. Now, that was for that level piece. Some of you had a level that was in there, so then you could line it up with your level that you have inside of there. And now we're going to figure out what the scale is. And you'll see that my ruler is right next to my ramp, and that's where I want it to be, because if it's too close, right? Oh, look, it's the whole screen. Oh no, look, it's the same width as my face, right? So as it gets farther back and farther away, it's getting closer. Right? I need to figure out about where I am. So that is where the ruler is even with whatever your ramp is, the edge of wherever you're rolling it down, actually. So, and then this one right here is I'm going to create a scale. I'm going to click, let go, new scale. I want this also to be something I can read. Create, and now I have this plus inside of a box, this little crosshair thing. And you're gonna do 2 clicks. It's a click to click and let go for the beginning, click and let go for the end. So click and here at the beginning, here at the end, and now I've set that distance and I can make that whatever I want. I'm going to say 30 centimeters. I could also say 1 foot. I could also say 12 inches. I could also say 1 meter. If that was a meter stick, that one, notice that one's not true. That is a 30 centimeters return. All right. So now anything that goes that far in the picture has traveled 30 centimeters. Now I need to track. I've set everything up. Now I'm ready to track the cork. So I want to set up a new track. My new track, I'm going to call this cork roll 6. Create. All right, there it is. There's the name. Now I want to track where this thing is. Wait, I have to reset. Go back to the beginning. Oh, I want to be here. All right, let's try, start over. There we go. If it's not working, just go a little bit slower. All right. So there's my object. Oh, I'm going to need my glasses so I can click on this a little bit better. Okie doke. And you're going to click on it. Nothing happens because you need to shift. Hold the shift button down. When you hold the shift button down, the screen, the axes go away. Everything goes away. And I turn from a pointer into the box with the crosshairs. So now I'm ready to track. Where is this thing right now? It's here. Click. And you'll see down at the bottom, I have moved over 1 more. And I have a 0 there. That's where I used to click. I'm going to click here again. And now I have a different time. Here's my X position in meters, and here's my Y position in meters. All right, but I need to click this so it goes all the way down. So I'm going to hit the shift again. Click, hit it again, click, hit it again, click, hit it again, click. Oh, there it starts to move. Click, 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 click. Things that you're noticing, I used a beige cork in front of a beige dresser cabinet, which is probably a bad idea. Should have put a sticker on the end of that now that I'm looking at it again. Okay, now I'm somewhere here. Here, now I have that cork in front of a white door that I really can't see. I want to say it's here, and I'm going to say it's here. You're starting to get the idea. It's a little bit, maybe next time we'll do a slow motion video, maybe get some more light in here. Now I'm really just tracking a smudge at this point. Oh, can see some a little bit more. There it is. There it is, there it is, there it is. Oh, this is where it hits the ground. Then it bounced up. Now that I'm at the end. So I want you to see, now let's play it. Now that I have the tracks and I've tracked its position in every frame, I'm going to hit play and you can see what those little dots are for, the 5 or 3 before and the 7 after. All right, that looks about right. All right. There's my data. There it is. Let's take a look at it. This is what's, so we have now done everything that we need to do tracking wise in the program. And you'll say to yourself, oh, Mr. Lubbs, wait a second. Oh, that's not 30 centimeters. 30 centimeters was inside each one. That's really should be 31 centimeters. Just click on it, double click, and I'm going to change that to 31 centimeters. And then you'll see all my numbers changed. So once I have this kind of in there, I can adjust and make movements. You're like, oh, wait, this isn't lined up or this isn't right. You can move that around and you'd be okay. Like, oh, I wanted to, that should have been down. All right, so take it and move it down or move it up. Let's move it up. All right. All the numbers back over here on the right, all adjusted because the points on the screen haven't changed. It's just how you refer to them to that XY coordinate system, because the XY coordinate system is arbitrary. The ball, my cork rolling down a board is what it is. That happened over there. I recorded it. Everything is already there. The XY coordinate system is something that I bring to the system. So I am allowed to change it, which I think is pretty cool.
Mr. Libs,
yes.
How do you those points like lined up? Like I have everything on like my screen for mine, but then how do I like, do I just, which button is that for like
that
tracking?
Is the edit project. And the points are just, I kind of did that for you just to see what they do. I don't think I've ever used them. Sometimes I use them to like, if I get lost in the picture and I don't know where I am, that will tell me about where it should be. They're just really there to help you out, not really there. They don't actually show up anywhere in the data set.
So then how did your data set come up then?
What do you mean?
Like, weren't like your points the ones that got the data set points? Like, didn't you like the buttons that you press on like along
the shift click?
Yeah, that part. Which one do we click to get those?
Oh, this one, the create new track. Do you have one of those yet?
Yeah, no, I do.
Okay, so then when you go back to the screen and you press the shift button down, the crosshairs should go, the XY coordinate system and the scale should disappear. Is that what's happening?
No, it's working now. Thank you. I got it.
Yeah, sometimes it works slow. All right. So next. Now I've got my data set here. I need to put it in another place where I can manipulate it. What is super nice that JSTracker just added, this is a private school somewhere back east. I'm sure it's in North Wolfordshire of Connecticut, run by people named Keenan and, you know, Darby. Open a spreadsheet for further calculations. And so what happens is, here's a nice position versus time. It will do velocity, acceleration, and forces on your objects, provided you know a couple things. Oh, it keeps doing this. For some reason it won't open in my school account. All right. Make yourself a copy. This is, shoot, what is this? This is a cork. Roll 6 period. Make your copy. Let me get rid of this. Now, all of the, if you take a look, if you click in those other values, you'll see that they do all of the equations for you. So if you're looking for an interesting way to have really Google Sheets do your stats homework, there's some neat things that are in here. All right. All this stuff floating around. It works pretty well. All right, so let's copy and paste. Where'd it go? Here it is. I want this. And scroll down in this, shift click, command copy, go over here. You click in this one. You click in the one that says click here. Don't click in the one below it. Command V, all the numbers pop in there, and then it does a little bit of math, and boom, you're done. Now you have velocities in the X and Y direction, you have accelerations in the X and Y direction, and you have forces provided you know what the mass of your object is. So what is my distance unit? I typed in centimeters on my scale, but let's go back and take a look at what it actually is. The program knows that it's centimeters, so it gives you meters. However, if you do British units, it gives you inches and feet. That's why you don't use inches and feet. So this is meters. And nicely, look at that. Everything across here changes. It's super nice. And my mass unit's probably kilograms, but I didn't measure my mass, so we're not looking at forces yet. We will be doing that Friday, by the way. All right, here we go. So we're going to pull accelerations using the X and the acceleration down the ramp. So here's my X position and Y position. In order to find the angle, let me draw this out for you. In order to find your angle, here's your ramp. We want to find out what this angle is. The tangent of that angle, let me close this down a little bit. Right, the tangent of that angle is your opposite or adjacent. In this case, this is your change in Y and the change in X, the change in Y over the change in X. Change in Y over the change in X is just the slope. So theta is the inverse tangent of your slope. And if you take a look on the on my graph, I have my X positions and my Y positions. I can easily type this into my calculator real quick to figure out what my change in Y is over my change in X. I strongly discourage you from picking two that are close next to each other. Pick them far apart. That gets rid of a fair amount. It minimizes the error of you in the in there. So if I would take probably my initial one and my this one right here while I'm still on the ramp. So I would take my change in Y. The change in Y here is, let's take this one. Oh, I'm just gonna change it, do this. 0.14862 minus change in, I'll use this one here. That's a good one. 0.4, 0.4, wait, 8 divided by, I gotta remember which one it was, this one. 0.76359 minus, remember it's final minus initial. 641, 641.
Mr. Love,
Yep.
what is it that you're talking about? Like you said not to make them too close.
Try to find the slope of when you're trying to find the angle of your ramp, don't use a protractor. Don't put a protractor up to the screen. You know where the object was. I know the object was here, and then the object's down here. I can figure out what the change in Y is over the change in X is the slope. But the slope is also the tangent. That's kind of what I derived back here. tangent of this angle is the opposite of the adjacent, but the opposite of is the change in y. The adjacent is the change in x. So the inverse tangent of the slope is your angle.
Do we use the website or whatever you just gave us, like, to figure that out? When we find the, like, when it says like 0, like the x for 0 and then the y for whatever number it is, and then when it ends, we figure that out and find the slope.
So how would you find the slope of the slope of your board or the slope of your ramp? Could you do that?
Yeah.
So once you find the slope of the ramp, the slope is just the inverse. Yeah, the slope is the tangent of the angle of your of the angle that we're looking for.
Okay. Okay. Thank you.
Yeah, it's like one of those things where like, wow, you know, the slope over here turns out to be the tangent of the thing over here. It's pretty cool.
When I copy paste the data from the video
Okay.
site into the spreadsheet, nothing shows up in the gray, like the shaded gray area. It doesn't get filled in like yours
Correct.
does.
Yes. Wait, nothing over. That means you just have to wait a little bit. Let it sit for a little bit, Adam, before second tangent.
Wait, Adam, you also might copy paste into the wrong box. You copy paste into the thing that says click here.
Yeah, I put it into the one that said click here.
Yeah, and all the numbers showed up, Adam?
Yeah, but they're not really aligned properly with the columns though.
Oh, okay. So they're not, are they on the left side?
Yeah, they're all too far to the left.
Yes. So that means they got input as words. You need to change the format so they're numbers. Do you know how to do that?
I'm not sure how to do that.
Highlight all of your numbers, like kind of highlight them all,
Okay.
and then go under format and turn them into numbers.
Okay.
See if that helps. While Adam is doing that, I got 36 degrees. It says negative. That's because it's a negative slope. So I'm going to get a negative answer. But at least I believe so. I got to double check that. Yeah, because it's an odd function. Change it goes like this. So if I get a negative, yeah, I'm going to get a negative value for the, yeah, that should be the same. Did that work, Adam?
Not yet. It doesn't, like when I highlight it and then click format, it just kind of flashes and then doesn't do anything.
All right, then I would go back in and recopy the data.
Yeah, I'm trying to do that right now.
Okay. I'm concerned about your massive amounts of clicking.
I'm trying to undo it, but it's also not working. This is weird.
Oh, yeah, just overwrite it. Don't try to undo. Because then it has to access its memory again to remember what you did.
All right, it's set to number, but it's still not aligning. Like when I check format, it has a check mark.
Next to number?
Yeah.
All right. I don't know. When you click over in the area, does it have the equations in the light gray area?
In the light gray area? No.
That means something didn't copy over.
What do you mean by equations?
So when I click on this number right here,
Uh-huh.
you see up here, there's an equation.
Yeah, no, there's nothing there.
Yeah, so you don't have the formulas didn't get copied over. That means you should probably throw that one out. Get rid of that and
Alright.
copy a new one in. That's probably what ended up happening. When you copied, did you make a copy?
Yeah.
Okay. Okie doke. All right. So now it's sitting in Google Sheets. We need to figure out now what to do. Now we need to make a graph. We need to do some manipulations. Your previous lab, you found an average. Average is like middle school level stuff. Now you're only going to use averages they're just boring. And they don't tell you a whole lot about what's going on. So we're going to do a graph. And so we're going to graph, we're going to graph all of this data. So I highlighted it because I'm telling Google, this is the data set that I'm interested in. And we're going to insert a chart. When you do this, Google's going to try to help you out. Google. Look at all these things I can do. It tries to figure it out. Problem is, Google never knows what I'm trying to do. So first thing is we use scatter plots. We always use scatter plots. Always use a scatter plot. When do we not use a scatter plot? Never. When you're going to think to yourself, you know what? I think Mr. Love I think everybody else is doing a scatter plot. I'm going to do a line. No, you should be doing a scatter plot. Always scatter plot. Always scatter plot. Are you using a line plot? Don't. Scatter plot. But mine connect the dots. Never connect the dots. And what am I looking for? I'm looking for position versus time. I want, well, really X and Y versus time. And X is the B column and Y is the C column. So let's edit the chart again. There's B and C. I can get rid of all these other ones that are here. And what I can see is, oh gosh. All right. The X and Y, I'm accelerating in both of these dimensions. One, because I can see because I'm curved. When I see a curve in one, when I see a curve in a position graph, that means I got that t squared. I'm accelerating. I'm accelerating in A and Y. That's because I'm going down. Right? I'm speeding up, moving sideways, and speeding up, moving up and down. This is a world, right? This path ends in pain and woe. We need to do something else.
So to make the scatter plot, what are you supposed to highlight? You're supposed to highlight the information on the right or the left?
So what I would do is you start with, I'm going to do this again, Agam, but start with highlight all the data that you are going to be dealing with. So I'm going to go all the way up through G40. It just allows you, this is the easiest way I've figured out how to make this go so far. You can see I've got curves in different places. So I'm going to stop here. And I would really like it if I'm only accelerating in one dimension, not two. So how do I do that? I'm going to I'm going to move my axes because I can move them wherever I want. I know that I'm accelerating down the board. So I'm going to take my axis, move it up here, and then rotate the axis so the axis is parallel to the top of the board. What does that do? Now let's play it and we can see some things happening here. What that does is now I am accelerating along the x-axis. I have no acceleration up off in the y-axis. I can just focus down in what I'm moving. All of my acceleration is now happening in the x direction because I've changed the x direction. My ball is still rolling down the ramp. I didn't tilt the ramp. I didn't change the ramp. I changed my x-axis. The quicker you release that x has to be horizontal and v has to be vertical, the easier this class gets. So I'm going to pause here for a second. I'm going to move this up just a little bit.
Wait, Mr. Lubs, how do you rotate the X and Y axes?
So you're okay with translating the axis? You were able to move it from side to side and move it up?
Yeah, I can move it side to side, but I don't know
Okay.
how like you rotate it like that.
Okay, so what I want you to see is as I slide down the x-axis, it turns into an arrow.
Oh, okay.
Now click and move.
Oh, okay, I see it.
Yeah, and if you want to move smaller bits, go farther out.
Okay.
So as you get closer in, then it moves very coarsely. As you move farther out, it moves very finely.
Okay. All right. Thank you,
There we
Mr. Lubs.
go. Yes. There we go. So now I've got a whole, I don't have to click again because the data is already there. It just resets to the new coordinate system. Let me see how well it looks. It looks like I'm below the axis. I'm going to move this down. I'm going to use this at the bottom of the. There we go. This is me just being a punk now at this point. All right. Nice. Okay. Now I need a whole new system. So I'm going to click open another spreadsheet. I'm going to actually, I don't want this. I'm just going to make a copy of this one because I've already made my graphs. Copy of cork roll. This is twisted axis. Cork roll 6. All right. So what's nice is it's going to copy the graphs as well. Did it copy where? Where's my graphs? Oh, it's thinking about it. There's my graphs. But I want this data now. So I'm going to copy this, control or highlighted, control copy, twisted axis, click here, control V, and bam. I don't have to remake the graph. I don't have to do anything. And now we can see that in the y-axis, which is the red here, I'm not moving at all until the very end, which is what happens because remember that cork bounced when it came off. Right? That cork bounced when it hits the bottom. Cork comes down and goes bloop, which is this piece here, which tells me that I don't want that piece. Nice. All right. And it looks like it doesn't. 1.12.
Mr. Lubs, if it moves a little bit on the y-axis after we like do it, is that fine?
What do you mean?
Like, wait, can I share my screen really quickly?
What is it like? Is it working its way up the y-axis or is it like wiggling?
No, it's like wiggling.
Then
like,
yeah,
sorta,
that is what it is.
for sure.
All right. So now I can ignore that y-axis. Now I'm going to go in and I'm going to get rid of that y-axis because it doesn't tell me anything. I do need to get rid of that last data set. So that's what that last time one is 39. So I need to get to 38. Now, hold on a second. Watch this graph when I go to 38. Bloop, it pops it off. Right? And it makes sense that I'm removing that data point, because in the y-axis, all of a sudden it picked up. I can get rid of that. It means it hit the ground. What do I see? What do I want you to see here as I'm moving along? That as I'm looking at this graph, I'm not looking at dots. In my brain, I have the motion of the cork rolling down that hill. And I know that that one at the end is after the cork bounced, so I can throw it out. I'm not looking at it and saying, well, does it make sense? Does it look like it fits with the rest of the data? No. If I go back and look, it's when it bounces on the ground. I don't want that in my data set. And I think I could probably, now I can make a pretty good case for that one right here to be thrown out too, because I think that one's when it hit the ground. But you know what? I'm just gonna wait a little bit. So what am I doing?
Mr. Love.
Yeah.
So we only remove the y-axis if our object like bounces off, like yours did.
So you have a horizontal line of dots that tell you that it's the same distance above the.
No, I mean, like, you know how you removed the red set of dots, right?
No, I removed the red set of dots because they didn't tell me anything.
Oh, okay, okay.
I removed the last dot because it hit the ground. And I knew that it hit the ground from the red set of dots.
Oh, okay, okay. That makes sense. Thank you.
Yeah, there's a couple little layers there, because now I have no acceleration in the y direction, because the y direction is now perpendicular to the board. It's not vertical. I have vertical acceleration and I have horizontal acceleration, but I'm not thinking in terms of vertical and horizontal anymore. I'm thinking in terms of parallel to the board and perpendicular to the board. Parallel to the board is the x-axis, perpendicular to the board is the y-axis. My cork did not fly off the board until it hit the ground, at which point I don't want it anymore. Does that kind of help? These dots no longer are just a graph that's there. These dots represent certain distinct points in the path of the cork as it's going down. Yeah, and here's some interesting things too. As it sits here, I know at the beginning, I held onto it for a long time. I probably don't need these either. The first 1, 2, 3, 4. I'm gonna throw out the first 4. So I don't need to start till 1, 2, 3, 4. I'm gonna start at number 10, which is 0.132. Is that this one there? The top number is the time number. The bottom number is the y-axis. Yeah, so I'll start at 1.32, which is number 10. So I'm not starting at A6 anymore. I'm starting at 10. Boom, there we go. There's a nice curve. That's probably a little bit after I left, but that's okay. Because of what I'm about to do.
Phillips,
Yeah.
what's the A10 and A6 for?
You'll notice those are lined up with the name of the number of the cell.
Oh, okay, thank you.
Yeah, so A10 is this cell right here. B10 is this cell. I cut it off. I went to A38. I started at I ended at A38 because A39 was after it bounced. So I don't want that. I don't want that in my graph. All right.
Wait, Mr. Loves, what if our data set looks like kind of linear? Like, is that fine?
It looks linear.
Like low key. Like there's like a tiny curve, but like it looks like pretty linear.
If it's position versus time, it should have a curve to it somewhere.
Oh yeah, I think I'm doing the slope one right now. Actually, never mind. I think we're good.
All right. So here's the position versus time. It all looks nice. I've got, now I'm going to put a title on it. Ooh, whoops. This is X versus T, my position versus time. And now this is where the power is, right here in this series. We're going to put a best fit curve to it. But I know x versus t, I'm looking for acceleration. That is x final equals x initial plus v naught t plus 1/2 at squared. Here's my equation that my graph is going to, that I'm going to fit to my graph. So I'm saying it's going undergoing this situation. I have a nice curve. Let's see how close it, let's see how well it fits. What are we doing? I'm saying it's doing this. I have a data set. I'm going to fit this to my data set and then compare accordingly. So here we go. I want, wait, what just happened? What am I graphing? I think I'm done. Here we go. Format, data series. I want a trend line. I don't like that word, but whatever, because I'm not going to put a trend line on. I'm going to put a trend curve. If something looks curved and you're going to treat it like a curve, that's what that t squared means. It's a polynomial. It's a second order polynomial. Treat it like a curve. Don't put a line on curvy things. Put a curve on curvy things. You will get ridiculed for doing something like this. All right, so here we go. I need a polynomial, and it needs to be second order. You can put a third order on it if you want to. You'll notice it doesn't change. It's because the third order polynomial, the rate at which the acceleration changing is functionally 0. So there you go. This is why you don't do a line, because you're going to be curve fitting to those data points, and I want to see the individual data points, and then I want to be able to see the curve fit that you put on there. If you use a line graph, the curve, your best fit line is going to be buried inside of there. All right. Now, wouldn't it be nice to know what that equation is? It's right there. The label for your curve or line, well, all lines are curves, is the equation. And here it is. 0.0341. So 0.0341 or 0.341, 0.03, yep, 0.0341 plus minus 20272 x minus plus 1.29. It'll always give the equation to you in terms of x. So how does this equation line up with this? Unfortunately, we use x for position, and Google uses x for their variable, but we can line it up and we can see this is that. Negative 2.72 is the initial velocity. That's probably because I started a little bit late, right? A little bit where this is, but that's functionally 0. And then 1.29 is this number here, is that coefficients. So x naught is 0.0341, v naught is negative 0.272, 1/2 a is 1.29. A is not 1.29. The coefficient is not a, the coefficient is 1/2 of a. So my acceleration is 2.48 meters per second squared from the graph. It's super cool. Now, do you want to see how well it fits? You're like, is this truly like, so this is the, yeah, when you do this, this would be polynomial regression. It gives you the best fit line or the best fit curve. It is the best fit curve, and then you can actually get a measure of how good is the best fit curve. That is the R squared. So if we go back to here, there's this little thing here. It's called show R squared. The best you can do is 1. Anything as the data spreads out and gets worse, you get less. Excuse me. You get less and less than 1. As you approach 0, you get it gets terrible. Yeah, that means your data is worse and is not very precise. This kind of tells you how close everything is to the line. Nice. So there you go. There's my position versus time, and I'm pulling the 1.29 as 1/2 my acceleration. Very nice. Now let's do the velocity versus time graph. So did I already? No, I want to insert. No, I want to insert a chart. Why would you do that? I want the velocity in the, so here I didn't select my data first. I'm going to select my data second. You'll see it's very much a pain. That's the data range. The data range is not the same range that you mean in your math class. So I'm going to select a new range that is from here to, I want here, D40, because D is velocity in the X direction. And I'm trying to do velocity versus time. I have the time column and I have the velocity column. And now it's just going to go, you still want, why does it say JSTrack? You'll look at it and you're like, why are you choosing this for me? The x-axis, I want it to be, whoa, that did not do what I wanted it to do. What the heck? D? Why do I want the axis to be the D? Okay, I'm changing it. Just gonna delete. Deleted. Delete. Now leaving that, I'm going to insert a chart. There. Now this looks a little bit less scatter. There's that. There's my x-axis. X-axis is the A, which is time. I want my y-axis to be D, which is the velocity in meters. That's this one right here. Oh, I gotta go back to this thing happening here, edit chart. I don't want B, and then I don't want C. You'll see this looks a little bit more spread out-y. All right. Nice. And if we remember right, I don't want this one. That last piece right there is pretty gross, if I remember right. So that is, I don't want that last one. I really want to get rid of it. I want it to be 38. Edit the chart. I want to go to 38. 38. Boop. That last one pops away. I also know I don't really start moving until here. Get rid of that one. I'm going to get rid of the first 3. So that is my first 3 data points. Take no, I don't want 9, so I want to pick up a 10. A 10. Bloop. There we go. You can see as it's moving faster, my velocity is starting to spread out because I don't know where it is because it's all blurry. Nice, nice. Now let's customize. This is V versus T. Close that. Here's my series. Now, what equation do I want to try to put on this? What's my model that I'm going to be using? Well, what has velocity and time and acceleration? V final equals V initial plus AT. So that looks like a line. It's a first order polynomial. So I need a trend line. Linear, and the label is going to be the equation. And it gives you in the form of mx plus b. which is not how this is set up, so I got to rearrange it a little bit. V final equals AT plus V naught. The equation that I have is 2.62 x plus minus 0.345. So here's my equation. V, that's a line, but I need to rearrange it a little bit. So now it's V final equals AT plus V naught. So V naught is negative 0.345. What did it say there? Oh, it's close. I also cut off a little bit more. The initial speeds on both of those aren't quite the same. That's all right. But then my acceleration, because this is this number, and this one is this number, 2.62 meters per second, which is pretty close to that. They will not necessarily be the same.